Okay, hello students. Today we'll see about electrostatics, and my name is Theodros Gazao. I'm your physics teacher. Therefore, today we'll see grade 10 electrostatics, that is unit 2. And we have some important terms: what is charge by induction, conduction, and conservation of charge, and electric field, and so on. Therefore, see this by yourself. Let us start from the selected discussion part. Therefore, the first one is charged object and electric force, conductors and insulators. This one is the selected point of this unit. Therefore, first let us see what is charge. Charge is what? A fundamental quantity of underlies all electrical phenomena. And the symbol for charge is Q, either small or capital Q, and the SI unit is also what? Coulombs. And the fundamental charge carriers is a negative. In negative charge is electron with an amount of minus 1.6 times 10 to the power of minus 11 coulomb. And the proton found in the nucleus of any atom carries exactly the same charge but positive. The same charge with electron, but it is what? Positive. That means for electron minus 1.6 times 10 raised to minus 19. For protons, positive 1.6 times 10 to the power of what? Minus 90 coulomb. And the neutron also found in the nucleus, but it is what? Chargeless. That means has no charge. When we say charged object and neutral or chargeless object, it doesn't mean that there is no any charge inside that element. But to say the particle is positively charged, the number of electron and the number of proton must be considered. If it is positive, this indicates that the number of proton in that particle is greater than the number of electron, and if it is negative, the number of electron is greater than the number of proton. ስለዚህ ምን ማለት ነው? አንድ ኦብጀክት ኔጌቲቭሊ ቻርጅድ ነው ወይንም ፖዚቲቭሊ ቻርጅድ ነው ስንል የኤሌክትሮንና የፕሮቶን ነምበር ላይ ነው ዲፔንድ የሚሆነው። ብዙ ጊዜ ኒውትራል ወይንም ቻርጅለስ ስንል ምንም ቻርጅ የሌለው አድርገን እናስባለን። ያ ግን ትክክል አይደለም። ቻርጅ የሌለው ማለት ሳይሆን በውስጡ ያሉት ኤሌክትሮንና የፕሮቶን ቁጥር ምን ከሆነ እኩል ከሆነ ነው ቻርጅ ካልን ነምበር ኦፍ ኤሌክትሮን እና ነምበር ኦፍ ፕሮቶን ምንድነው እኩል ነው ማለታችን እንጂ ምንም ኤሌክትሮን ምንም ፕሮቶን የለም ማለት አይደለም። ስለዚህ ፖዚቲቭሊ ቻርጅድ ለማለት ደግሞ በውስጡ ያሉት የኤሌክትሮን እና የፕሮቶን ነምበርን ስታወዳድሩ የፕሮቶን ቁጥር የሚበልጥ ከሆነ ፖዚቲቭ ነው፣ የኤሌክትሮን ቁጥር የሚበልጥ ከሆነ ደግሞ ኔጌቲቭ ነው ማለት ነው እንጂ ኤሌክትሮን ብቻ በውስጡ ያለ ወይንም ፕሮቶን ብቻ በውስጡ ያለ ወይንም ምንም ቻርጅ በውስጡ ያለ ማለት አይደለም፣ የሌለ ማለት አይደለም። ስለዚህ ቻርጅለስ ስንል ኤሌክትሮን እና የፕሮቶን ቁጥር እኩል የሆነ ማለት ነው እንጂ ምንም ቻርጅ የሌለው ማለት አይደለም ማለት ነው። Okay, the other thing is the law of conservation of charge. The law of charge, that means the law of charge says that like charges always repel and unlike charges will what? Attract. That means positive charge, there is what? Repulsive force. Negative charge also what? There is what? Repulsive force. But if it is positive and negative charge, there is what? An attractive force between them. Positive or negative. If it is like charge, there is a repulsive force. If it is unlike, there is an attraction force. Consider four charges A, B, C, D, which exists in a rigid space, and charge A attracts charge B, but B repels C repels D, and D is positive. We have what? Three charges: A, B, C, and D. From the last expression, D is what? Positive. This one is positive. And the interaction between C repels what? D. The interaction between C and D is what? Repulsion. Since D is positive, C must be what? Positive. Because they repel each other. And when you go back, B repels also what? C. That means B is also still what? Positive. But A attracts what? B. Therefore, A is negative. Therefore, if D is positive, it repels C. That means C is what? Positive. Since C repels B, B is also positive, and A is attracting B. Therefore, A is what? A negatively charged body. Okay. Charge is one of the four quantities in physics that is conserved during any process. And let us consider one example. Consider two charged spheres of equal size carrying positive 6 coulomb charge and negative 4 coulomb respectively. The spheres are brought into contact with one another for a time shift to allow them to reach an equilibrium charge. They are separated, then they are separated. What is the final charge on the spheres? Now, when we bring these two, when two spheres come into contact with each other, charge will transfer, but the total amount of charge is what? Conserved. Here we have 6 positive and 4 negative charge. Therefore, the total charge is 6 plus what? 4. Positive 6 plus minus 4. And the total charge becomes what? Positive 2. Positive 2. Therefore, and this magnitude of equilibrium charge, when they separated by dividing the charge evenly, is keeping a charge of how much? 1 coulomb. Because their sum or their total amount of charge is 2. Therefore, after they brought into contact and keeping them separately or keeping them separated, dividing by each charge evenly, we can have in each positive 1 coulomb. Positive 1 coulomb. Okay. The other thing is conductors. Conductors. When we say conductors, conductors are like metals, and it's not all metals, but metals having 1 up to 3 outermost shell electrons. That means metals having with a valence electron of 1 up to 3 are conductors. These conductors have an extra or free electron in their outermost shell. Therefore, this free electron moves from one point to another particle. Therefore, because of this free electron, these metals or conductors conduct electricity well. And the other thing is insulators. Insulators are like wood, glass, and other substances, but these insulators does not have any free electron in their outermost shell. Since they don't have any free electron there in their outermost shell, they couldn't conduct electricity. They couldn't conduct electricity. Therefore, conductors conduct because of their free outermost shell electrons. Insulators will not conduct electricity because they don't have any free electron in their outermost shell. Now, the other thing is charging a substance. When we charge substances or materials, we can use 3 techniques. The first one is charging by rubbing or charging by friction. When we rub 2 materials, let us say we have a glass and silicon cloth, and if you rub this glass by using this silicon, electrons are escaped from this silicon. Electrons are escaped from this this glass, and transferred to what? The silicon. Initially, the glass as well as the silicon is neutral, and electrons are removed from this glass and transferred to what? The silicon. Therefore, there is a deficiency or a decrease in electron in this glass, and there is an excess amount of what? Or increase in electron in the silicon. Therefore, since there is an excess amount of electron in the silicon, we have what? We have here negatively charged material. Here also there is a deficiency of electron. That means there is an excess amount of what? Proton. Therefore, this one is what? Positively charged. Therefore, when we charge materials by rubbing or by friction, both materials must be initially what? Neutral. And when we charge, both materials are charged, but what? Oppositely and evenly. They charged oppositely and equally. When we say equally, let us say the amount of electrons escaped from this glass is 3 electrons, and the excess amount of electron in this silicon must be what? 3 electrons. Therefore, the number of charge is also similar. Here we have a deficiency of 3 electrons, and here we have what? An excess amount of 3 electrons. Therefore, charging by rubbing, when we charge a material charging by rubbing, there is a transfer of electron, and the the material which gives or which removes electron becomes what? A positively charged, and which accept electron becomes what? A negatively charged. And the two bodies must be charged equal. That means they have equal amount of charge. Okay, the other thing is charging by contact or by conduction and induction. When we say charging by conduction, this one is induction. First, let us see charging by conduction. In conduction, we have one neutral object, and one charged object, either negative or positive. When we brought a negatively charged object to this neutral object, the positive charges are what? Brought to this part, and when we make contact with the neutral object, electrons are escaped from this charged object and transferred to what? The neutral object, and there is an excess amount of electron in this substance. Then at this time it becomes what? Negatively charged. But if you brought a positively charged object, electrons are attracted to this part and positive charges are what? Repelled, and this one is what? Positively charged, and this positive charge attracts electron from this object and transfer this positively charged object. Then here there must be created what? A deficiency of electron. That means we have an excess amount of proton. Therefore, it becomes what? Positively charged. Therefore, charging by conduction, when we charge materials by conduction, one of the two must be what? Charged object, either positively or negatively. And if you brought a negatively charged, we make the neutral object negatively charged. If you brought a positively charged to the neutral object becomes what? Positively charged. The second one is charging by induction. In induction, let us say we have one situation here. We brought a positively charged object to the neutral object. This one is neutral, and from this neutral object, electrons are what? Pushed? No, this is not right. It's not positive. This one must be what? Negatively charged. And when you brought a negatively charged to this, a positive charge is attracted and a negative charge is what? Repelled. And when you ground this with the earth, these pushed electrons are moved to what? The earth. Moved to the earth, and finally the material becomes what? Positively charged. Therefore, to charge materials by induction, we must brought, there is no contact with the two objects, the neutral and the charged object. We simply brought to nearest to the neutral object, and the neutral object positive charges are attracted and electrons are pushed, and we connect with a conducting wire to the ground or earthing this neutral object, and these pushed electrons are moved away from the neutral object, and there must be what? A deficiency of electron in this neutral object. That means the object becomes what? Positively charged. Okay, this is how we can charge materials. The other thing is Coulomb's law. According to Coulomb, he stated that between two charges there is an attraction or repulsion force, depending on the type or the sign of the charge. But this attraction and repulsive force is dependent or directly proportional with the product of the two charges, Q1, Q2, and it has an inverse square relationship with the separation distance between the two charges. And he cancels this proportionality and adds one constant. That constant is K, which is equal to K Q1 Q2 over what? R square. And K is equivalent to what? 1 over 4 pi epsilon naught, and epsilon naught is this much value. And for a vacuum, K is equal to 9 times 10 to the power of 9. 10 to the power of 9. It's given, since it is a constant in equations, it must be given. This is Coulomb's law. And when we apply Coulomb's law, here we have a positive charge, here we have a negative charge. Therefore, there must be what? An attractive force. an attractive force. Therefore Q1 is this much and Q2 this much. And if the force between the charge is 2 Newton, what is the value of R? The separation distance. Therefore, to do this, as you know, force is equal to KQ1 Q2 over R square, and by making crisscross and arranging and finding for R becomes what? Under radical of KQ1 Q2 over the force, and K is, as I said, 9 times 10 to the power of 9 divided by the 2 Newton, and here we have what? Q1, it's not written, Q1 is 2 times 10 to the power of -6 times what? -4, simply taking the magnitude 4 times 10 to the power of what? -6. And finally, rearranging this, you can get how much? 0.19 meter or 90 centimeter. In B, we are asked to find that where could you place the third charge, Q3, 1 microcoulomb on the horizontal axis, so that there would be no net acting on Q3. Find the equation for X, where X is the distance from the 2 microcoulomb charge to Q3. That means we plug the charge at this point from the left, such a like. And we put from the left and X. Now, the sum of the two forces. That means, let us say this one is F2 and this one is F1, and no, Q1, Q2. This one is Q1, Q2, and this one is Q3. And these two charges exert a force on this Q3. Therefore, the force exerted by Q1 on Q3 is F1, 3, and the force exerted by Q2 on Q3 is F2, 3. And the sum of these two forces is equivalent to what? 0, according to the equation. And we are asked to find or to solve for X. And rearrange this, and finally, you can get the value of X. Try by yourself this. Okay. The other thing is electric field. Electric field is a region where an electrical force is exerted. Therefore, electric field is a region where an electrical force is exerted, and it's given by electric field strength is equivalent to the force divided by the charge, or electric field is equal to KQ over what? R square. Also an equation. And the field lines for this one is for positive charge, for negative charge, this one is for negative charge, it's what? Into the charge. But for positive charge, it's out of the charge. The field lines are out from positive into negative charge. The electric field lines in a region can also represent a path a positive charge would follow in that region. Remember, electrons, that is negative charge, are moved when a charge transfer, but electric field lines drawn always what? From positive charge would move. That means they out from positive charge into what? A negative charge. The electric field due to the point charge Q at a distance r away from the center of the charge can also be written using Coulomb's law. This is, as I wrote before, electric field is equivalent to what? KQ over R square is also the equation for an electric field strength. Okay. Electric field lines. For positive charge, it's what? Out of the charge, and for positive, into the charge for negative. And for uniformly charged plates, for example, for a capacitor, capacitors have two parallel plates, and for such a like, the field lines, the field created between the two, this plate and this plate, is uniform and what? Strong. The electric field strength created between two parallel plates is always uniform and what? Strong. Okay, the other thing is electric field inside a conductor. always in a charged material, charges are lies on the outer surface, on the touchable part of the sphere or the material. Therefore, inside that material there is no charge. Since there is no charge, there is no what? Electric field. ምን ማለት ነው? በማንኛውም ቻርጅድ በሆነ ማቴሪያል ላይ ቻርጆችን የምናገኘው ከውጪ ነው። in the outer surface ነው የምንነካው ፓርት ላይ። ውስጥ ምንም ቻርጅ የለም ማለት ነው። ውስጥ ምንም ቻርጅ ከሌለ ኤሌክትሪክ ፊልድ ክሬት እንዲደረግ ቻርጅ ያስፈልጋል። ስለዚህ ውስጥ ምንም ቻርጅ ስለሌለ ውስጥ ምንም አይነት ኤሌክትሪክ ፊልድ የለም ማለት ነው። ኤሌክትሪክ ፊልድ የለም። ስለዚህ አንዳንድ ማቴሪያሎች ከኤሌክትሪክ ፊልድ ኢፌክት ነፃ እንዲሆኑ ወይንም በኤሌክትሪክ ፊልድ አፌክት እንዳይሆኑ የምንፈልጋቸው ማቴሪያሎች inside this conducting material እናስቀምጣቸዋለን። that technique is called as shielding. Shielding means putting a material inside a charged materials, inside that charged material, because inside that charged material there is no electric field, because there is no charge. For this reason they do not have any effect on that materials. And in the outer we have an electric field because we have what? A charge. For this reason in the outer part we can calculate by using electric field is equal to kq over r square. R is the distance or the radius. Okay, this is all about electric field strengths and electrostatics. Until next time, have a nice time.